Okay, so for example, graph the solution set of y squared over 4 plus x squared over 9 is less than or equal to 1 as the first equation of a system, and the second, or inequality of a system, and the second inequality of the system is y is greater than negative x plus 1. So first, I'm going to solve the equations that are associated to those to find the boundaries of the regions that I'm going to shade. So I start with y squared over 4 plus x squared over 9 equals 1. This is an ellipse with center at the origin. And with a, the value of a is 3, and the value of b is 2. The 3 coming from the square root of 9, and the 2 coming from the square root of 2. The major axis is in the x direction. The points on the ellipse are solutions because of the equals in less than or equal to. So the ellipse is solid, not dashed. So I'm going to graph it here, and it looks like that. I just went from the origin, I went left and right, the 3, which is the value of a, and up and down b, which is the value of, up and down 2, which is the value of b. So the other equation, y equals negative x plus 1, is a line with slope negative 1 and y-intercept of 1. The points on the line are not solutions, since it's greater than, not greater than or equal to, so the line is dashed. So I graph that there. So then you take test points to see which regions the solutions are in, and shade those regions. For both these inequalities, we can use 0 as 0 because it's not on either boundary. So I want to know, do I shade inside the ellipse or outside? Do I shade the left side of the line or the right side? Kind of like that. So I put 0 in the first inequality. I got 0 squared over 4 plus 0 squared over 9 equals 0, which is definitely less than or equal to 1. So it's the inside of the ellipse that I shade. So I shaded it kind of lightly there. And then for the line, I tried 0, 0 again. And the question is 0 greater than negative 0 plus 1? I'm just plugging 0 into this equation here. And that's false. So I have to shade the opposite side from where the origin is, opposite side of the line from where the origin is. So that's over there. And then you take where they intersect, and that's the answer. So I drew it on a separate graph so it's less messy, so it's easy to see what's going on. So that's the region that's the solution set. Okay. The ellipse is a solid curve, and the line is a dotted line, and everything in between those two on this side of the line is a solution, including the boundary of the ellipse, that part of the boundary of the ellipse. Okay, that's it for that section.